And now we come to the final layer of modern physics. Talk about one more interesting phenomena. There was a question back in the days: why do metals glow when heated? It couldn't be explained. Where did that light come from when you heated something up? And let's take a look at the history of the atom. Um, the old atomic model basically was by John Dalton, which basically said that the atom was just a little ball. And that was it. And everything was made up of these tiny little elements called atoms. And then later on, when electrons were found and they needed to be rubbed off with static electricity and stuff, it was proposed that it was more like a pudding or a muffin with little chocolate chips in there. And that's what the electrons were like. They were kind of, this jelly kind of thing stuck in there. And then the Rutherford model, which came basically because when they started to shoot alpha particles into atoms, into a material, they found that mostly it would just go right through, and then sometimes would come right back. And it kind of detected that the nucleus must be a really tiny mass in the middle, and then that came up with the Rutherford model, which was more like the solar system and the electrons orbiting around. Of course, that still didn't explain the phenomena of why things were glowing when they were heated up. So again, looking at the atomic timeline, it was later proposed that electrons could be in different energy levels, so they could be either on this orbit or that orbit. An electron in a higher orbit can lose energy and go to a lower orbit or gain energy and jump to a higher orbit. But it was at a higher energy here and a lower energy there. And that was what was happening, that when light went from the higher energy to the lower energy, it obviously conservation of energy required that energy to go somewhere, and so it came out like a photon or a piece of light, and that was why things glowed when they heated up. Was when they heated up, they jumped to the higher level, didn't want to stay there because it was unstable, came back to the lower level. When it did, it gave off a particle of light, which was exactly equal to the difference in the energy between those two, law of conservation being observed and followed. And so they were said that Bohr proposed that the electrons could only be found in specific orbits. It wasn't like you could have any orbit, it had to be a specific orbit for each where it was stable. And so that was the Bohr model, where you now have the nucleus in the middle, and the electrons could be either in this shell or that shell, orbiting over that far or that close. So this would be the ground state, the lower state, and that would be when it was excited. So energy comes into the atom, the electron gets excited, jumps to a higher level, and then after a while comes back to the lower level, giving off a photon. And that's why things glow. That kind of fixed and understood, made people understand what was going on. And it turned out that every atom had its own set of atomic levels based on its nucleus and how far they needed to be stable. And so we had different energy levels. And if it jumped from this energy to this energy, it might give out a red light because that's a low energy change. But if it went all the way from n equals 3 or shell equals 3 to n equals 1, then it would give up a high energy wave, which would be like a blue wave. From here to here is also a middle energy wave. And so they said that if each shell was fixed, and that means that these frequencies must be fixed. And so each atom must give out a specific set of frequencies only because it had a specific set of shells that the electrons could be in. And so that basically meant that each atom must have its own unique fingerprint, which tells you exactly what energy photons can be observed. And so when we look at that, we see that when we looked at, say, mercury or nitrogen, or looked at one of these elements and we pass light through them to see what kind of electrons were being emitted in this case, we see that there was a certain light that was given off for each element as you pass the current through it. And so we saw these